5.1 Basic Concepts of Probability, Video 4. Okay, it's time to define probability. I think most of you kind of intuitively know what probability is, but if I had to give it a formal definition, probability is the percent of the time we can expect an event to occur if the experiment is repeated many, many times. How many is many? Several thousand, tens of thousands, millions. Now, obviously, we don't have the time to do that, although there are some computer programs that can replicate an experiment a ridiculous number of times. Probability is more of a theoretical thing. If this happened over and over, what fraction of the time would we expect a certain outcome? The notation for probability of an event, and we're going to call a generic event capital E. Remember, capital letters represent events, also known as collections of outcomes. But the probability of an event E is denoted P of E. For those of you who had algebra before, you might remember function notation, something like f of x. This is along the same lines. It's actually a function. It's called capital P for probability, and the input is some sort of event. The output is the probability of that event occurring. Don't use lowercase p. That will mean something different down the road. For example, let's say the experiment is you flip a coin and we want to know the probability that you flip heads. What do you think that probability would be? What percent of the time would you expect the coin to come up heads if you flip it? I think most of you know that that answer is probably 50%. And you would be correct. Now, when you answer a probability, you can answer it as a percent, but you could also answer it as a decimal. 50% as a decimal would be 0.5. You could also answer it as a fraction. 1/2 of the time, we would expect a coin to come up heads. But what about drawing a card? What do you think the probability of an ace would be? Pause the video for a second and see if you can come up with the probability of an ace. Okay, hopefully you paused it, or maybe you just knew it. But let's think about it. Let's come up with the answer as a fraction first. We're drawing one card out of 52, and we want to know what's the probability we get an ace. I think it seems intuitive to say, out of the 52 cards, only 4 of them are aces. So it stands to reason that the probability of drawing an ace would be 4 out of 52. We could turn this into a fraction. Well, it already is a fraction, excuse me. We could turn it into a percent, but in order to turn it into a percent, we would need to turn it into a decimal first. Turning fractions into decimals is pretty straightforward. Just remember that a fraction is a division problem. So if we did 4 divided by 52, we would get approximately, and we'll take this to 3 decimal places, 0.077. It's actually 0.76923, but we're going to round it up to 0.077. And now that we have it as a decimal, we can turn it into a percent. Remember, to turn a decimal into a percent, you move the decimal place 2 places to the right. That would put it between the 2 sevens. And stick a percent sign on. So when we draw a card, we can expect to draw an ace about 7.7% of the time. Well, would that actually happen? If I drew a card 52 times in a row, would I get exactly 4 aces? Or if I flipped a coin twice, would I always get a head exactly once? The answer is no, so what's really going on here?